Hello everyone and welcome back. In this lecture we'll continue our discussion on the SMS message spam ham classification. So in the previous lecture we have split our dataset into training and then testing datasets. The next thing we'll do is instantiate the count vectorizer object and we'll save it in a variable called vector and we'll set that to be equal to count vectorizer. Once we have that, we'll call the fit method on our count vectorizer object so that we can learn the vocabulary of our training dataset. Let's do that. So we have our count vectorizer object and we'll call the fit method and then pass our xtrain object. And once we fit our count vectorizer with our xtrain object, we'll need to transform this into a document term matrix. For that we'll call the transform method. Okay, and then we'll save our document term matrix in a variable called xtrain dt matrix for document term matrix. Okay, and that will be equal to our count vectorizer, that's the fitted count vectorizer now, that transform. Okay, and then pass xtrain. So this will transform our xtrain dataset into a document term matrix. So the count vectorizer accepts a one-dimensional object and then transforms it into a two-dimensional object. So now if we check the shape of our xtrain document term matrix, we'll see that it's a two-dimensional object. Let's print the shape. You see now it's 3900 by 7125. We'll come to see what the 7125 is. So here, once we instantiated our count vectorizer object, we call the fit method and then we call the transform method. We could have done this in one step also by calling a method known as fit transform. Okay, so we could have also done this. We have our count vectorizer object and then we can simply call fit underscore transform and then pass your xtrain dataset. You could have done this also in a single step. Okay, I just wanted to show you that. So now let's get back to our xtrain document term matrix object, and if you look at it, it's a sparse matrix 3900 by 7125 sparse matrix. What do you think this is? Just to give you a clue, in the previous lecture our sparse matrix was 3 by 7, right? So this 3900 represents the number of rows, whereas 7125 represents the number of columns. So in this case, our columns are words, right? Or tokens. So 7125 is the number of tokens or words, which are represented as columns. Okay. And this 3900 is the number of rows that we have in our xtrain. So if you check the shape of xtrain, it's the same, 3900. Let me go back to the previous lecture. So the shape of xtrain is 3900. Okay, so that's our xtrain dataset. Now we also need to transform our xtest dataset into a document term matrix, right? Because we need to convert it into a two-dimensional object, right? So the count vectorizer object will take a 1D object and then transforms it into a two-dimensional object by calling the transform method, right? So let's do that for our xtest dataset, and then once we convert it into a document term matrix, we'll save it in a variable called dt matrix for document term matrix, and that will be equal to our count vectorizer object that transform, and then we'll pass our xtest object, then run it. Now if I call the xtest documenter matrix object, what do you think the shape will be? So the shape will be, if I go back to see the shape of xtest, let me print it here, print xtest.shape. So xtest is 30% of our dataset, which is 1672. So the shape of xtrain documenter matrix will be 1672, 1672 by our number of features, which is 7125. 7125. Remember, we'll always have the same number of features, otherwise our models won't work. Okay, so let's run this cell. So we have a sparse matrix with a shape of 1672 rows by 7125 columns. Okay, and one important thing to note here is when I converted our xtest dataset into a documenter matrix, we only applied the transform method, right? We did not apply fit first and then transform next, as we did with our xtrain dataset. Okay, so any new word in our xtest dataset will be dropped. Okay, so when we use the xtrain dataset to train our model, we analyze the vocabulary of xtrain, right? That's the fit method. Whereas we're not using this fit method in our xtest. So anything new that's seen in our xtest dataset will be dropped. Okay, that's one thing to remember. Now we are ready to build our model. And for building our model, we'll be using multinomial naive Bayes. Multinomial naive Bayes is a good model for this kind of text analysis where we know the number of our features. Okay, first we'll need to import it from scikit-learn. Let's do that. So from sklearn.naive Bayes, import multinomial NB. Multinomial NB. What we'll do next is instantiate our multinomial NB model and then call the fit method to train our model with our xtrain documenter matrix and ytrain dataset. After that, we'll call the predict method and pass the xtest documenter matrix for prediction. Okay, let's go ahead and do it. So once we instantiate our model, we'll save it in a variable called nb model, and we'll set that to be equal to multinomial nb. Now that we have instantiated our model, let's call the fit method on our nb model that fit, and then we'll pass our xtrain documenter matrix, and then we'll pass our ytrain. Now we can call the predict method on our fit multinomial model. So nb model that predict, and we'll be making predictions based on our xtest documenter matrix object or dataset, right? And then we'll save this in a variable called y prediction. So this will be the prediction. Y prediction will represent the prediction. And for comparing the result, we'll print out the accuracy score and compare this y prediction and our y test. Y test will be the actual result. So let's import metrics before we can run the accuracy score. From sklearn, let's import metrics, run it. Now we can say metrics that accuracy score, right? And then simply pass our true result or true values, which is y test, and then our predictions will be y prediction. Okay, let's print this and run it. Okay, so here we have an accuracy score of 98%. So our model has a 98% accuracy in labeling messages as spam and ham. We can also print out confusion matrix for our result. We can say matrix dot confusion underscore matrix, and then pass your true result, which is y test, and then your predictions, which is y prediction. Run it. So this is your confusion matrix. This is your true negative, true positive, false positive, and false negative. It looks good, only a few of those are miscategorized as false positive or false negative. So in the next lecture, we'll analyze this confusion matrix and try to see why those are incorrectly labeled as ham or spam. So let's summarize what we did in this lecture. We instantiated our count vectorizer object, and then we used count vectorizer to convert our datasets from one-dimensional to two-dimensional. And once we did that, we fit our model to learn the vocabulary of our X-train object. And once we transformed it into a documenter matrix, we saw that we have a sparse matrix, 3900 by 7125. This 7000 represent the number of tokens or words, which is the number of columns. And then we also used the transform method to transform our X test into a documenter matrix. After that, we used multinomial naive Bayes for our model. We instantiated our model and then called the fit model to train our model with the X-train documenter matrix object and the Y-train object or dataset. And then we made predictions off of our fitted multinomial NB model. And here we saw that we have an accuracy score of 98%. We also printed the confusion matrix for our result. And we see that we have some results labeled as false positives and false negatives. Thank you, everyone.